Okay, for number 9 we're doing a piecewise function. So for piecewise functions, they're made up of 3 different pieces, but we have these conditional statements that come after that. This tells you which equation that you can use depending on what value you have for x. So to answer these ones where you're just evaluating this function, the number inside has to match with these conditional statements. Okay, so let's go ahead and start with that. We have first f of 0. The 0 inside, that would not belong to the first equation because we don't have an equal sign next to the 0 there, but we do have an equal sign for the second one. So for these, you're only going to have one equation that's going to fit with these numbers that you have here. So that means for this, if it's 0, automatically my answer is 3. So actually there's nothing to work out on that one. If x is 0, automatically we just put 3 down for the answer. So that would be it. Okay, that only works for that one specific x value. Next I have f of negative 3/2. Okay, so that's negative 1.5, and that actually fits with the first equation. Negative 1.5 is between negative 3 and 0. So what I'll do is I'll put the negative 3/2 in for x, and I want to get common denominators, so I can do 6/2 minus 3/2 is going to equal 3/2. So 3/2 would be the answer. For 9 would be greater than 0, which means that you're going to use this equation there. So you're going to do square root of 9, which equals 3. Okay, we just put it into that one. Again, that's the only one that works for numbers that are greater than 0. Any positive number, you're only using the bottom equation there. Then we have negative 4. Okay, now negative 4 does not work with this one because it only goes up to negative 3. It's not 0, it's not greater than 0. This is one of those cases where the number actually does not fit any of the 3, and if you have that happening, what you have to put is undefined, because that number is not defined for any of the equations we have. Now, the next thing we have to do is do graphing. Now for graphing, what we're going to do is make a table, and we're going to do that for the first one and the last one. Now this middle one, all that's going to end up being is a point. So I'll do that one last. I want to go ahead and graph the first and the last one because I have to make tables for these. If you have something that's linear, if you have x that's raised to the first power like I have here, all you need is 2 points on your table. If you've got something else like square root or x squared, something like that, that's going to require you to plot at least, I would say at least 3 points for that one. But this one is a line, 3 plus x, so all we have to do is 2 points. Now, when you graph these, the numbers that you use in your table, they should be numbers that match your conditional statements that you have originally. Now, even though the 0 is not included, I'm still going to go ahead and plot that. And the reason why is because we have to have a reference point of where the line's going to end. I know that that point's not included, but it'll end up being an open circle on my graph. I have to know where to plot the open circle, so that's why I want to put 0 on my table here. Okay, I plug these numbers directly into the expression. I have 3 plus negative 3 is going to give me 0. 3 plus 0 equals 3. So now what I can do is I can write my list of points here. I get negative 3 comma 0, and I get 0, 3. Now, when I plot this, the negative 3, 0, since negative 3 is included with the equal sign, that's going to be a closed circle there. But the bottom one, 0, 3, that's going to be an open circle because the 0 is not included. So if I have the equal sign, it's going to be closed circle, otherwise it's going to be open circle. So that's my first plot for my table. I'll do the graph in a second. I just want to get the table values first. Okay, now next. The next one I'm going to look at is y equals square root of x. Definitely the first value I want to pick is in the one that I have here for the conditional statement. So yes, even though that's not included, I want to definitely have that on my table as a reference point of where this graph is going to begin. And then I just want to include values that are greater than 0. So any values greater than 0 I can put on my table. Now I'm going to purposely pick some values that are going to be easy to evaluate. I'm going to pick a 1 and a 4 because I know that square root of 1 is 1 and square root of 4 is 2 to make it easier to graph. So I'm going to pick these numbers here. So square root of 0 is 0, square root of 1 is 1, and square root of 4 is 2. And if I put that in here, I get my 0, 0 coordinate, 1, 1 coordinate, and 4, 2. Now let's talk about whether these are going to be open or closed. The first one, 0, was my conditional statement. That one, there's no equal sign, so that one's going to be open circle. But the other ones, as long as it's not exactly equal to 0, it'll still make that equation satisfied. It'll make it true. So therefore, I'm going to close. These other ones are going to be closed circle. The only one's open is going to be this first one. Let's plot this information. Now that we have this table complete, we're over here. I'm now going to plot that. So hopefully you have all that information down. We're going to start plotting, and we'll put all of it on the same graph. Okay, here's the 2 points that we're going to plot. We're going to need a closed circle at -3, 0. Okay, so I got a closed circle there, and at 0, 3, I have an open circle. Then there'll be a line connecting those. It's a straight line because I have x to the first power. That takes care of the first equation. Let's jump to the last one. Square root of x if x is greater than 0. Okay, square root of x, here are the different points I have. I have 0, 0, that has to be an open circle. I have 1, 1, which is closed. And I have 4, 2, that's closed. So far now I have that. I graphed the first one and the third one. However, I still have the middle one to deal with. Okay, so the middle one says I have, if x is 0, the y value is 3. What this is going to do is right now I've graphed the first and the last one. I have 2 open circles. What the middle one does is it actually closes up one of your open circles. When x is 0, you're at 3. All this is a plot. So you're just going to plot the point 0, 3. So 0, 3 means it's going to close this one up there. So this will be your final graph. You have 2 closed circles there. You still have an open circle at 0, 0. We've done the evaluation, and so that would be your finished graph.